whenever you're ready, okay? Oh, and I am gonna do this again.
Fantastic. It's such a pleasure to talk to all of you today. Just a little bit of high level before even diving into what it is I actually do. It's a little bit more about the journey, and I'm going to share my screen just so we have it as a nice backdrop. But on a very high level, because buildings are 40% of all carbon emissions, we have to all work together and utilize technology to make sure that building performance is not so unique. It's not so for the 10% or the top 10% of the project. So it is for 100% of the projects. And that's really what brings me back to cove.tool and why I created it with my team in the first place. We started about 3 years ago. It was a team of three, started on our kitchen table, and now we're a 35-person company. We started with having done 200 plus projects as a sustainability consultant across the Southeast. And now we've been able to empower over 10,000 architects and engineers across 22 different countries to actually be able to do performance modeling, which is really what, again, brings me back to technology. So here's what cove.tool even is. This is my vision of how computation, how data, how technology can empower us all. So cove.tool is a holistic automated building performance app. So things that only experts could do once upon a time, and it would take easily 200 to 300 hours for an expert. And of course, multiply that by the billing rate. I'll let you all do the math. Well, it can now be done in about 20, 30 minutes by just about every single person on the team. It can be done by every architect, every engineer, every contractor, the people that are just getting out of school, people that have been out of school for years and years, to really make sure that it's not a one-off, it's not a unique thing. And we do that by a few key items. One of the things that I think technology can offer is automation. We put that to the test. We put that to use. For example, directly inside the app, of course, not only do we allow the entire team to collaborate in real time, so we're using the same basis of design, but people are able to just type in their address. Every architect or every contractor, or sometimes, gosh, even every engineer may not know what the local regulation is, but if it's automated just based on your address, for example, if I type in um, Detroit, there where I have never been, it automatically picks the local energy code. If I do something in San Francisco, it automatically picks the local energy code for me. It automatically knows that if I'm doing an education building in California, what my lighting power density would need to be, what my appliance power density would need to be, what my schedules would need to be, what kind of R value should I have as a very minimum R value to get started with. And I think that's the power of automation that we can use to make our practice just more efficient. So we don't have to spend time looking at basically the guides, the journals every single time when we're doing a brand new project. So not reinventing the wheel. So that's part one in terms of automation. The other aspect of it that I think is equally important is accessibility, to make sure that the workflows that we're utilizing are not tied into one or another kind of a box, so that the team member that is all about Revit can work in the same workflow and collaborate with me, while the team member that uses SketchUp or Rhino or Grasshopper or ArchiCAD or really anything else can also collaborate with me on the same workflow, to make sure that I'm not alienating team members um, that have a slightly different way of working than I do, because there's no one right way to do it. We all know that. We've all experienced that. When I was a consultant, I mean, y'all probably have this happen to you all the time already, but especially when I was a consultant, I noticed that even not only firm to firm, or really even studio to studio, and sometimes even within studio, project team to project team, the kind of platforms and workflows that were utilized can significantly vary. And being able to use the same basis of design and the same workflow so we can all collaborate and use the same information can be quite empowering. And then being able to have this data available to us in a really, really easy way. For example, right here, I have the model pulled in from Revit, and all of the context is automated. I don't know if any of you have spent the time, but I remember back in my consulting days where we had to outline these buildings, count the number of floors on Google Earth, and extrude it to really model the context and spend those 8 to 12 hours of billable hours. Well, we don't have to. Again, going back to automation, but also going to democratization and making sure that everybody can do shadow analysis, not just the few people in the office that are really good at scripting or the few people in the office that are known as the tech gurus or the tech geeks, but so that it's available to everybody because that's what we need to make sure that we're able to have the impact from a climate change standpoint. Why shouldn't everybody have shadow analysis available at their fingertips? Why shouldn't everybody have property information, zoning information available within the same platform that we're doing design decisions on? Why shouldn't everybody have view analysis to really understand what kind of views we have from the site? So let me actually go ahead and hide the roof. Why shouldn't I know that, oh, my building, based on how I've designed it, has 88% quality views and 77% of that are sight lines and 94% of them are sky and context? That on level 3, I have 94, and on level 2, I have 92%. Why shouldn't we have that information available to us so that we can bake that into our design aesthetic? We've all been in those conversations where, well, somebody on the team wants us to reduce the amount of glass. And if we can't quantify why this glass is helping us in terms of the quality of views or the amount of daylight or the glare reduction, it becomes a really challenging case to make, which is why having data empower us throughout the design process in a simple, easy way so that it's not for those unique projects is just so critical. And the reason why automation comes back to be so, so critical is because not every project could have afforded this 250 hours or so that it would have taken to do all of these analysis types that I'm running through literally in a click of a button. But every project can afford 10 hours of time. And that's really what brings everything together. Same for energy analysis or benchmarking 2030 reporting. Why shouldn't our 2030 reporting be 100% every single year for every single firm? If it doesn't add any additional overhead, it's just the right thing to do. Um, well, it just makes the whole process much, much simpler. And even more importantly, why wouldn't we optimize? Why wouldn't we look through thousands of iterations with each vertical axis being one possible decision where with glazing, multiple different glass products, multiple different wall products, roofs products, so on and so forth, balance those against embodied carbon, lead points, first cost premium, money that we have to spend up front, payback years, energy savings, and then really just be able to use the sliders. If the owner tells us, you know what, you've only got the ability to offer like options that are less than 10 years of payback, well, so be it. If you want to have low embodied carbon, well, that's great. And then if our budget is kind of confined to be under $50,000 that we can spend on any energy efficiency measures, that's perfectly fine too. What's the lowest EUI we can do for that? Well, there's a few options there. We can spend an additional $35,000, get a 2.3-year payback, and get to 27% energy savings. In certain scenarios, I've even seen developer-driven projects do reverse engineering, where they're not trying to hit any energy savings, but they're trying to make the building cost less to hit code minimum. Well, that's exactly what machine learning algorithms like we see right here can offer to us, where it even keeps becoming more and more intelligent as we make more models. If we all do kind of our models in our silo, in our firms, well, that's all the information we have. But if we prototype and gain from each other's knowledge, of course, in an anonymized way, we can all learn from each other and grow as an industry. Right now, we have over 15,000 projects in cove.tool that are all getting significantly better because of the sheer volume. We have 22 different countries that are modeling their projects in cove.tool that are all getting better. Again, not just from their own unique knowledge, but also from their peers. And that's what we got to do. That's exactly what technology can do for us. Here's the Emory University Campus Life Center in this particular 117,000 square foot student center project that was $90 million. The team was able to save $1 million in pure construction cost while saving 40% in energy and hitting their LEED Platinum targets and saving 240 hours in design time, in the time that it took to run all of these analysis types. The team utilized the automation and the platform to do all of the climate analysis, something that would have easily taken 4 to 10 hours, pull together, understand the conclusions, but to have it really, really easily available. They were able to do the energy analysis every step of the way. Every time they changed the design, they were able to understand the impact on carbon, understand the impact on energy, understand the impact on the benchmarking, where they shook out on the 2030 range, able to do daylight and glare analysis. Every time we changed an interior wall, they were able to see, is the daylight penetrating deeper or not quite as deep? Anytime the massing was modified, be able to quantify that with real metrics. If somebody on the team is pushing to cut out all the shades on the project, and I've been in those conversations, I'm sure so have you, be able to quantify that, hey, if we cut out all those shades, the glare situation is not going to be looking quite as good with good and easy to understand glare maps. Being able to utilize data to really understand how to punch the openings, where to punch the openings, what facade strategy even makes sense. Be able to see if it makes sense to use low flow fixtures or gray water reuse or use native plants versus turf. And also, of course, be able to do the cost versus energy optimization like this team did. And here, the architecture and the engineering team came up with multiple different options for windows, right? They were biased to a particular, brand of glass that they wanted to use, but it can be any brand, right? Solar Band, Vitro, PPG, use different types of wall insulation, whether it's rock wool or Owens Corning, whether it's spray foam, bat insulation, whatever typology you're considering. Same for roof sensors, shades, photovoltaic panels, and different mechanical system types. Does it make sense to do geothermal? Or is it more cost effective to get to our performance targets to not do geothermal, but add a little bit of PV? Being able to run that nuanced level of optimization with these thousands of combinations is exactly what this team was able to do to pinpoint exactly the lowest cost way to get to their EY target of 45 and below. So that's really where I see the value, the power of automation, the power of us all being able to gain the overall industry benchmark, make sure that it's not just the top 5, 10% of the projects, but is every single project. Let the machines, let the computers, let the automation do the tedious work so we can focus as designers, as engineers, as contractors on the more complex problems. That's everything I had for you today.